Hi guys, welcome. Today we will take a look at SEIRAL library, and basically this SEIRAL library is a UART library, and it's really fast API, and it can easily create instances of multiple UART ports. Like if you are using nRF5 2840, you can use multiple UART. I would recommend using this library. Previously we have seen some simple UART communication, but if you are using some advanced stuff, then I would recommend you using this library. Let's see what are the benefits and features of this library. So this library provides us three modes. The first one is the blocking mode, second one is non-blocking interrupt mode, and the third one is non-blocking interrupt with DMA. In the blocking mode, the processor is blocked until the peripheral has finished transmitting the data, so the processor cannot do anything else in the blocking mode. It's normally simple to implement, but it's not good in terms of performance. The second mode which this library provides is non-blocking with interrupts. So in the interrupts, whenever you are transmitting some data, and once the data is being transmitted or is ready for transmission, an interrupt will be generated. If there are so many interrupts, this will cause the processor, this will consume a lot of cycles, so we use another technique, which is the third one, and this one is the non-blocking interrupt with DMA. In this technique, the processor is free. Basically the processor is just initializing the DMA task, and then the DMA handles all the transfers from the peripherals to the memory, and from the memory to the peripherals. So this is really useful, and today we are just going to see this third mode, which is non-blocking interrupt with DMA. Of course, the other two modes are very easy to implement as well, because we will write down all the code. Let's see how we can program this. Okay guys, first of all we are just going to create a new project. So go into the PC, in the C directory. Here we have nRF SDK, and we go into the examples folder, and we will go into the peripherals, and from here we are just going to copy this example, which is the SEIRAL. We are just going to copy that, and we will go back into my projects, paste it here, and go into this project. If you are using nRF5 2840, just open the PCA 10056. If you are using nRF5 2832, then open this PCA 10040, and I will go into the blank SES folder, and I will open the SEIRAL PCA 10040 EM project file. Okay, we can see some code here. First of all, I'm just going to remove some stuff. Let's remove everything so you can see how everything works. Okay, now we are ready to program the SEIRAL library, and first of all, let's see what are the configurations. So if you go into the SDK config, go into the CMSIS configuration wizard. Here in the drivers, you can see the UART is enabled. Basically, when we are using the DMA, we are using UART, so make sure it's enabled, and then in the legacy drivers it should be enabled as well. So let's close this. So let's start programming. So the first thing we need to do is we have to define a queue size, because we will be using queues, buffers, and FIFO all together, and we will configure everything. So first of all, let's define. The next thing we need to define is we can either use the sleep handler, or if we want to use the sleep handler, we can define it. And if you are using some soft device and power management, then I would recommend you to not to play with the sleep handler, because it's going to be handled by the power management. Okay, the next thing is we have to define the sleep handler. Whenever the peripheral is free, the sleep handler is going to be called. So You can define it here, or you can just put the null in the place of sleep handler. So I'm just going to use it for now. Next thing is we need to define a UART handler, which is going to handle the events. I'm just defining the function here, and later on we will see what to do with this function. So the next thing is we have to define some of the other stuff like the configuration. So make sure these are global configurations. Let me name it as UART0. Let's enable the hardware flow control. Along with the default priority. The next thing is we have to define the FIFO size, so I'm just going to use and then we have to define queues along with the FIFO. Let's name it as serial queues. And the next thing is we have to define the serial transmitter and receive buffer. Whatever the size we are going to give, it's going to generate the events according to that. Make sure you give it the right size, and once we finish with the code, we will see and we will experiment with this thing as well. Now we have to pass this to the serial buffer. Name it as serial buffs and pass the TX and RX. Now we have to pass these queues and buffers configuration to a serial configuration. Let's name it as serial config. And here we are going to define the mode of transmission. So I'm just going to use the DMA, so I will call the nRF serial mode DMA. We can choose the IRQ, DMA, and then the blocking mode. So if we see this, we have 3 mode: polling, IRQ, and DMA. So I'm just going to select the DMA. First of all, we have to pass the queues. Then we have to pass the buffers. Then we have to pass the event handler. And the last one is the sleep handler. We can just put the null value here if we are not using the sleep handler. Okay, this configuration is done, and the last thing is we have to define the handle. Name it as serial UART. If you are using multiple UARTs, then you can give it another name like UART1 or UART2. I'm just going to give it serial UART. UART0 is the UART which is going to be used, so I'm just going to put the 0 here. Okay, we have defined all the settings, and let's call this handler and perform something within this handler. And let me save some data. Okay, created a variable, and now we will use so the serial TX done means whenever a byte is transmitted, this is going to generate this event, and we can do something in this event. This event is going to be received whenever we receive some data over UART port. So this event is going to be called. Okay, and for the default, okay, so this is done, and the next thing is we have to call this configuration in a function which is going to initialize everything. And before doing that, let's initialize the LEDs. Let's create a simple message when we are going to transmit that message. And now we need to transmit this message. Before doing this, we have to initialize the UART, because we have just defined everything but we haven't initialized it. So we need to initialize the UART. First of all, we have to pass it the handle, which is serial UART. Now we have to pass it the configurations, and the last thing is we have to pass it these configurations, serial config. Okay, the UART is initialized, and now we have a message, and we are just going to transmit this message. So to do that, we will call a UART function. Let's transmit it over UART, so I'm just gonna give some delay first, and then transmit a message. And here we will give it serial UART, the handle, and the message is this one. So the pointer to this message is basically its name, and the length of the message, I'm just going to put null there. And the last thing is we have to give it a timeout. Okay, the data is going to be transmitted. After every 1 second, this data is going to be transmitted. So last thing we need to do here is we have to indicate some data being transmitted. So to do that, I'm just gonna use a simple function. And here, let's say LED1 is just going to be toggled whenever a data is transmitted, and let's toggle another LED for receiving the data. Whenever we receive the data, we are just going to toggle the LED. Let's say LED4 in this case. 3 means the LED4, 0 means the LED1. Okay, so first of all we need to build this code. Oops, I missed a little stuff here. Okay, we are good to go. Okay, this is done, and now we have to initialize the clock as well and the power management unit, because we are calling the sleep handler. Okay, the code seems to be complete, and let's change this to max timeout. Or it's okay, just let's save it, and I'm just gonna build it, and make sure your device is connected. Click on the connect with the target, erase all, and then download it, and let's see if it's working or not. So I'm just gonna open the PuTTY, click on the serial terminal. I'm connected with the port 7, and I'm just gonna open this, and here you can see it's transmitting this data, and after every transmission it's toggling the LED, but it's toggling it so fast we can't see it. So let's change the code a little bit to see what's happening. So I'm just gonna go into the code, and I'm just gonna put one more character here. So it's just going to add one more character. So what's gonna happen is, at this character the light is going to turn on at the end of each transmission. It's just a test. Connect, erase all, download it. Oops, I haven't built it. Let's build it and then download it. And here you can see now I've added the dot last character, and you can see here the LED is blinking as of every transmission. So what's happening here is, every time this transmission, the serial write function is transmitting data, after every single character it's inverting the pin. So on the last character it's inverting the pin as so we can see it as 1. So let's see if we can transmit, we can turn on the other light as well when we try to transmit some data. So if I click here and try to press any key from the keyboard, as you can see the light 4 is turned on, and if I press any other key it's turned off. So it's transmitting the characters, and the light is the LED 4 is turning on and off. So let's see some more stuff. So what I want to do is I'm just gonna say that I want to see whatever character here I'm transmitting. So for that let's write more code. So let's read the data in this character. So and let's say the timeout should be 100 milliseconds. Okay, we have read the character, and now we are going to transmit it back. So if you don't want to use the error code variable, just call this void. So it's just gonna cast it to void, so we are not going to use that value. It's similar. And let's flush whenever you are writing something. So if you want to make sure the buffers are clear, we have to call another function which is called flush. So okay, so the UART serial, and here is the timeout. So I'm just gonna put 0 here, so it's just gonna flush it whenever the serial port is free. Now it's completed, so let's build it. Click with the target, erase all, and download it, and let's see. And let me reset it. Okay, if I try to transmit some character like AST, as you can see it's printing whatever I'm sending it, and it's printing other data as well. And the last thing right now we need to see is, if we want to, I don't want my processor to be using too much interrupts on each character. So what if I want to receive more characters, and then I'm just gonna generate an interrupt. So for that, let's see the buffer. So if I change the buffer size for the RX as 4, so now it's just going to generate an event after the 4 values are received. So this is going to be a good thing. If you're transmitting or receiving data larger than 1 unit, then it's this is a good practice. So right now I'm just gonna make it an array of 4 so that everything goes smooth. So what it's going to do is it's just going to read it, and then it's going to print the values. So okay, so it receives 4 characters, and then it's going to generate this event. Otherwise this event is not going to be generated unless it has received 4 characters in its buffer. So it's changed here. So let's see, build, and now I'm just going to connect, erase all, and then download it. And if I go here, let's reset it again so we can see. And now I'm just going to write the character 0 IKL, and here you can see that I have written the 4 characters and it has printed it. So it received the 4 characters and then it's going to print ASDF. See, if I try to write ASD, it hasn't printed anything. So if I press U, the 4 characters are completed, so it's going to generate an event and it's going to read all of these characters and then it's going to display them. So I hope so you have gotten familiar enough with this UART library, and I will recommend you use this library, and don't use the DMA unless it's really high speed transfers and a large amount of data. So it's a general tip for you, and I think so this is enough for today. All the code along with the information along with the comments is going to be available for download in the description of this video, so be sure to check it out and download it and play with the code. If you are new to my channel, please be sure to subscribe to my channel, and if you have any questions you can ask me in the comments below. And thank you very much for watching. See you in the next video.